What's up everyone, Patrick here, welcome back. Moving on to the next video, very similar to the previous video. What we're going to do, take these trinomials, verify that each of them is a perfect square trinomial, then we're going to factor it. So when I'm going through this video, I'm assuming you watched the previous one, where we dealt with trinomials where the a value is 1. Here, notice that the a value is not going to be 1, but we're going to go through the same process. So first we're going to verify it with that formula we've been using, and the formula is a squared plus or minus, remember this could be positive or negative here, this middle term, and depending on if it's positive or negative, it's going to factor into a plus or minus b, and that's going to be squared, right? So if we can take each of these, rewrite it in this kind of format, then we verify that it's a perfect square trinomial. Now, as I mentioned in the previous video too, your teacher, your textbook may not be using this formula. They may just expect you to factor it, like with decomposition, and get to this format, and we're going to be doing that as well. But just in case your teacher does want you to use this formula, take these kinds of trinomials, rewrite it like this. I'll go through that initially too, but then I'll also go through the full factoring process. Okay, so let's start off with part A. We got 4x squared plus 20x plus 25. Now what we want to do here is we first, well, at least personally what I do, is I try to take the ends and then rewrite them in that format so we could get the a and the b value pretty easily. So this 4x squared, notice we could rewrite that as 2x squared. The 25 we could rewrite as 5 squared. So comparing it to the formula, we could tell the a value is 2x. We could tell the b value is 5, right? We got b squared, 5 squared, so the b value is 5. So then, because this is a positive, we're working with a plus 2ab case, so we'll have plus 2 times the a value, which is 2x in this case, times the b value, which is 5. And notice 2 times 2x, 4x times 5 does indeed give us 20x. So because we were able to take this and rewrite it in that format, where the a value is 2x, the b value is 5, that verifies that it's a perfect square trinomial, at least with the formula way, if you are doing it that way. And what it's going to be, what it's going to factor to is just a plus b, right? Because it's a positive here, so it will factor into 2x plus 5 squared, like that. So that's if we do it with the formula. Now, what if we were to do decomposition on this? So if you're not using the formula, if you got to factor it fully, first thing you always check with factoring, can you take out a greatest common factor? And notice in this case we can't. In all of these, there's not going to be any greatest common factor because we're more so working with the perfect square trinomial portion. But lots of times you could take out a greatest common factor. So just be aware of that, and we will do videos in this section where we will be taking out greatest common factors. But in this case, in all these cases, there won't be. This is just going to be a straight perfect square trinomial that we can factor right away. So we can go into decomposition. So because the a value is not 1 in this case, notice the AC value, which is 25 times 4, it's going to be different than the C value. When the a value is 1, the AC value and the C value were the same. So two numbers that multiply to 100 add up to 20. And those two numbers are going to be 10 and 10, 10 and 10. So decompose this. Then from these two, we could take out a 2x. Then from these two, we could take out 5. And then notice we could take out a 2x plus 5. And we'd be left with 2x plus 5. So the same factor, 2x plus 5 squared, notice it's the same thing we got when we used the formula. So this is going to factor into 2x plus 5 squared, like that. Moving on to the next one, we got 9x squared minus 6x plus 1. So notice we're dealing with the negative case. So a squared minus 2ab plus b squared, and that's going to equal a minus b squared. So let's first get the a value and the b value. Now this one we could just rewrite as 1 squared. So notice the a value is 3x. Notice that the b value is 1. So we'd end up with minus 2 times the a value of 3x times the b value of 1. Notice that when we multiply these, we do indeed end up with negative 6x. So, because we're able to rewrite it like this, then we know it's equal to a minus b squared, 3x minus 1 squared. So that's what it is going to factor to. Let's confirm it though with decomposition. A value is 9, b value is negative 6, the c value is 1, ac value is 9. Two numbers that multiply to 9 add up to negative 6, negative 3, negative 3. Okay, with a perfect square trinomial, when you're doing the decomposition, those two numbers are going to be the same. So we can decompose that middle term into minus 3x plus 1. From the first two, what can we factor out? A 3x. And then from these two, we could take out a negative 1. And then we could take out a 3x minus 1, like that, right? Which ends up being 3x minus 1 squared. So whether you use the formula or you use decomposition, you should get the same answer. Now moving on to part C. So we have 49x squared plus 112x plus 64. Let's work with these ends like that. So notice the a value, 7x, the b value is 8, and because we're working with positive, plus 2ab, so plus 2 times the a value times the b value, and then notice 2 times 7x gives us 14x, times 8 gives us 112x. Okay, so it does, this is in that format. We're able to rewrite in that format, which shows we're dealing with a perfect square trinomial. Because it's a positive, we're dealing with the a plus b squared case, 7x plus 8 squared case, like that. Okay, now if we do it with decomposition, notice that the a value is 49, the b value is 112, the c value is 64. So the ac value, if you multiply these two, is going to be 3,136. So what two numbers add up to 3,136, add up to 112? It's going to be 56 and 56. Okay, so working with much larger numbers. In this case, these two numbers are always going to be pretty much half of that b value. So decomposing that middle term into those two values. From these two, we could take out 7x. Right? We'd be left with 7x plus 8, and then from these two, you could take out an 8, and we'd be left 56x divided by 8 gives us 7x, 64 divided by 8 gives us 8. Take that out, and we're left with 7x plus 8, which is what we got with the formula as well. So this would end up being 7x plus 8 squared. Right, so just showing that all of these are indeed perfect square trinomials. Moving on to the next one, we got 16x squared minus 24x plus 9. Like that, first thing we do, let's rewrite those ends in this format. So we could get the a value of 4x, we could get the b value of 3. We have a negative here, so we're dealing with the minus 2ab case in the middle. So we have minus 2 times the a value times the b value. And then notice negative 2 times 4x, negative 8x times 3 does indeed give us negative 24x. And then this, it would be a minus b, 4x minus 3 squared. Okay, but if you do it with decomposition, A value is 16, the B value is negative 24, the C value is 9, the AC value is 144, 9 times 16. What two numbers multiply to 144 add up to negative 24, negative 12, negative 12, negative 12, negative 12. So we decompose like that. Then from these two we could take out a 4x, so we'd be left with 4x minus 3. And then from these two we could take out a minus 3. As expected, that bracket should be the same. And again, as expected, that second bracket should be the same as the first. So we end up with 4x minus 3 squared, which is what we got when we used the formula. Moving on to this last one now. Notice this last one, it's in a bit of a different format. We went over this, a similar question like this in the previous video. Now you can take this and you can rewrite it if you want, like that, right? This and this are the same. And this would factor, it's going to end up factoring. We're going to do the work, but that would factor into that. This is going to factor into that. And both of these are the same. If these are the same, that means these have to be the same as well. Okay, and I showed how these kinds of brackets, when you square them, are the same. I'll do it again though at the end. But if we work with this first format, same thing, we just rewrite this as 7 squared. Sorry, this should be 4x squared, yes. And then we got 2x squared like that. So notice that the A value is 7 in this case, the B value is 2x, and we end up with, there's a minus here, so minus 2 times the A value times the B value. And notice negative 14 times 2x does indeed give us negative 28x. So because we were able to take this, rewrite in this format, we showed it's a perfect square trinomial. Because there's a negative, we're dealing with the A minus B case, A minus B, 7 minus 2x squared, like that. Right, which is this. Now again, if you wanted to rearrange this, okay, you could get the A value to be 2x, the B value to be 7 if you put this here and then this here. And over here, you'd end up with 2x minus 7 squared. Both of them are the same thing. I'm going to show you at the end why. Now, if you do this with decomposition, you can rearrange it. I did that in the previous video, but let's actually just, let's just keep it like this. The B value is negative 28. The C value is 4. So the AC value is going to be what? 196. 49 times 4 is 196. So what two numbers multiply to 196 and add up to negative 28? That's going to be negative 14, negative 14. Okay, so from there, we decompose that middle term. Okay, now if you did the decomposition with the 4x squared in front, the 49 at the end, you'd still get negative 14 here. That middle term would still decompose into those two terms. But if we work it like this, how we're given, we could take out a 7 from the first two. We could take out a minus 2 from these two. So we're left with 7 minus 2x. Sorry, my bad. From these two, okay, in steps here. It's just a different format, so even I'm getting a little bit, it's taking me a little longer. So negative 14, 4, because there's a negative, we're definitely taking out a negative. Let's go back to the fundamentals. 14 and 4, we can take out a 2. And then there's an x in both of them, so we're actually taking out a minus 2x. Right, so Negative 14x divided by negative 2x would give us 7. 4x squared divided by negative 2x would give us negative 2x, like that. And now those brackets are the same. I noticed that I did something wrong because the brackets were different, right? Remember, with decomposition, that's always a nice check. If these are not the same brackets, then there was a mistake somewhere. So that's how I caught that. And we're left with 7 minus 2x, which is 7 minus 2x squared. If you did it the other way, you'd end up with 2x minus 7 squared. Both of them are the same thing though. So I showed this in the previous video, but just to drive the point home, I will show you in this video too. So when we just look at them separately, this and this are not equal. But if we square them, then they are equal, right? Because no matter what you plug in for x here, like if we plug in, let's say 4, we'd end up with 7 minus 2 times 4, which will give us negative 1. Here we'll have 2 times 4, which is 8 minus 7, which would give us positive 1. So those two wouldn't be the same, but once we square it, negative 1 to the power 2, 1 to the power 2, those are the exact same thing. So the reason why these are equal is because what we can do is we can factor out a negative 1 from this, and when we do, it ends up being 2x minus 7. It ends up being negative 7 plus 2x, which is the same as 2x minus 7. And then when we square that, then we'd have negative 1 squared, 2x minus 7 squared. We could take that exponent, distribute it to the terms we're multiplying. Negative 1 to the power 2 is positive 1, and we're left with 2x minus 7 squared. So we just showed that both of them are the same thing. Okay, so if you get an answer like this, textbook shows an answer like that, they're actually the same thing. So you didn't get it wrong, you got it right. Okay, so just a couple of more examples of where we use the formula to verify that it's a perfect square trinomial, and then use decomposition to factor it.